Ladies and gentlemen, good evening. Tonight we're going to talk about and look into the Java framework called Byte Buddy. And what it does is it actually enables us to create classes on the fly, runtime. So that means that when our program is running, then we can create and override methods and actually create whole new classes that we want to use. And why do we want to do that? That is a very good question, but it is actually they actually try to answer that question themselves with an example. If you want to deal with security, for instance, then it would be more safe to. Let me just go up in the documentation right here. You go to bytebuddy.net if you want to look at the documentation, and it is amazing what they've made right here. When you read about what they've made right here, you get a much better understanding of the class loader, and you can also see what kind of problems they have been targeting. And it is really interesting what they made here. I don't think that I have ever made use this framework, but that's a personal thing for me, because I think that usually when you're going out in the direction of reflection, or in this case generating your own classes runtime, then I think it's a little bit messy, and it's also difficult to test. And you could probably, in most cases, they actually also say that themselves. Most cases, you could actually come out of the problem by redesigning your model, your whole model. If you create a new domain model or something like that, or if you create some other classes, you could solve the problem like that instead. But it is fun to look at, nevertheless. And since then, I've spent time actually reading up on this framework right here. That means that now you also have to hear about it. Of course, you can always turn off the video. I know that, or go to the next video. But it is actually quite interesting. So try to stick with me and actually see the possibilities, because they want to be more efficient than existing frameworks, and also reflection. With reflection, you actually call some native code, and it is called right away when you're running the reflection. With the Byte Buddy framework, you are generating new classes, you're creating new classes that you do not need to load in the class loader right away. You can load those classes later on when you need them, or maybe you never need them. Then it was actually waste that you actually loaded them, and that is the strong side of Byte Buddy. And they actually use ASM, so you can also go and look at ASM. It's kind of it is also very interesting. But we will focus on the Byte Buddy framework tonight. And here's the example where they have, where they say, in this case, you could actually use Byte Buddy instead, and you could actually generate your code, because in some, or usually, if you're using Spring security, then you can actually, then you will annotate your method with something like secured or something like that, and then you will need to have a certain role in order to access that method right there. But the point is here that it's actually a bit unsafe, because you actually have a framework right here, and if you access the framework, then you still get an instance of the class. And down here, then they have the Byte Buddy way instead, where they are actually overriding the delete everything method. So if you want to delete everything and you do not have the right role and the right, if you don't have the rights, you don't have the right role, then it's actually hard coded into the method that if the user is not equal to, if it is equal to admin, then it's okay to go and delete the whole thing, delete everything from the database if that was the case, or else throw an illegal exception. They're not authorized. Legal state exception not authorized. So it is a bit more secure when it is hard coded than when a framework is deciding that it should be that it should be that the code should be called or not. So that is one. That is actually the use case that they show that the show where Byte Buddy could actually be used. But and here they are actually, then they're comparing with other existing libraries like CGlib and Java Proxies and Java Assist. And they say that they're much faster. You can see here are the numbers, blah, blah, blah. Very, very interesting. Let us jump to some code. That is the fun part, right? That is what we want to do. First of all, I've created a new project by pressing File, New Project, like this. And then I chose Spring Initializer, Java 15. I chose Gradle. I pressed next. Of course, I gave it a good name. I also chose 15 right here. And then I pressed next. I ticked off Lombok. I chose Spring Web like that. And I pressed next, finish. Then I ended up with this project right here. Then I went and added the body framework right here, which is currently in version 1.10.18. So you can just add that like that, and then you're ready and happy and ready to go. First of all, let us do something. Very easy. Let us do something simple. I'll create a new space package right here. I have some more advanced tests in this test right here, but they're a bit advanced to start on. So we will start with something easy instead. So I'll go right here, then I'll create a new spaceship class right here, spaceship. And then we can also all follow what's going on right here. So I have a spaceship class right here. I'm going to skip the fields today, and I'm going to focus on methods instead. So let us say that we have a spaceship right here. It returns a string, and it's we have a method called fly around like this, and it returns wobble. That is the sound of the spaceship. What we can do then, first of all, let us create a new test. I'll enter up on the class name, create tests. Yes, thank you very much. I would like to create it for the member, fly around. Yes, let us do that. Let us make them public so we are sure that we can actually run them. Public, like that. And I'm going to copy a line, and that is this line here. Actually, I did not have to copy this line right here. But actually, we need to create a new Byte Buddy like this. So this is how we are starting the fun. Then we can choose to subclass. We can choose to subclass something. We can also choose to redefine. Then we just erase all the code that is already there. The point is that we should actually have some classes or some interfaces that already exist, because then it's easier to call the code afterwards. Also, when we want to define which code should be called, then it's much easier if the code is already located in a static method in some class somewhere. Then we can just do something called a method delegation. That is the point of it. But we need to subclass from something, or we need to redefine something, or we need to rebase from something. And the difference between those three are described a bit better than I did right here in the documentation. Let me just see if we can find it. Right here, here it is. We have redefinition right here. Then we have the rebasing right here. And then the cool thing about rebasing is that then you actually keep the original code. So if you had some code in the original class, you keep that code. You can still call it. You can still call it because it is actually still there as private something, and then original. Then it gets this $original right there in the method name. We are going to subclass. It's much easier to understand a subclass. That means that we are actually creating a new class, and then we're extending the spaceship. So that is what we're doing right now. So I'll say a subclass spaceship right here. And yes, it is okay if you get a headache while trying to follow this, because I also got a headache trying to figure this out. It's very, very complex, especially when you're dealing with something as abstract as classes that you cannot actually see the code for. You need to take the original classes, and then you need to try to think of what is going on yourself. So here we have the subclass. Then we can actually go for. That's actually not enough. We could actually just make the class right here, but usually what we would actually do is that we can also name it, and we can also implement something, and we can also redefine methods. First of all, let us name this. We do not need to name this, but I'm going to name this class right here. We can call it dk.mike.slow spaceship. That means that now this class right here that I'm creating from the spaceship class, that is actually named slow spaceship. I do not need to do this. I can just skip it if I want to. Then I will get I think I'll get a Byte Buddy from the Byte Buddy class or something like that from the package instead. I will get it from another package, and then the spaceship will actually have the same name, just in two different classes packages. So here we have the name dk Mike. That's slow spaceship. Then we will actually go for the method. And here we can match something. That here we can use some matches. And in this situation right here, I want to get the name of the spaceship, which is the method. Sorry, that was fly around. I'm going to copy it, and then I'm going to say name. So this is the matches right here, and we want to import it statically. Yes, let us just see what just happened right there. See, now we got this element matches. They have a lot of element matches that can be used. That means that now we're targeting that that one method right here, which is named fly around, and then we want to intercept it. Intercept. That means we want to do something else than what is happening already. And here we can use fixed value. Fixed value. This is the easiest example. Then we can say value, and then we can say swoosh instead. Yeah, swoosh. Maybe it's also coughing a bit. It's a slow spaceship. Cough. So the spaceship is coughing a little bit, and then we are making the class like this. It is not loaded yet. If we want to load it, then we call loaded, get loaded, and load it like this right here. I'm just going to check right here. It was just load, and then we need to give a class loader. You can actually create a new class loader, and you can have there are different strategies. You can have the existing class loader, but you can also create a new class loader, and there are benefits of doing this. And you read about that on Bytebuddy's homepage. Why we would create our own class loader and why we would not create our own class loader. I'm going to create. I'm going to use the existing class loader right here. So I'm actually going to get the test right here. Get class loader like this, and then it's going to be. So now it's loaded. Then I can say get loaded from it, but we can also stop here, and then we can see what type we actually are returning. We can actually see right here the type that we are returning right now is a dynamic type. Loaded because it's loaded, and if we took the class before, then you can actually see here it's named dynamic type unloaded. So if we stop one line before, then it would actually be unloaded. So now it's actually loaded. That means that we can actually get the class. That means, and usually we do that with the get loaded like this. If you read the documentation, then you would see that then you will just right away say new instance. But this is actually being deprecated because new instance, the method new instance from on a class is being deprecated because it will actually hide exceptions for it will actually eat up exceptions, so we can actually not see in all the cases what's going on. What we need to do instead is we need to use the constructor. So it means we need to get constructor instead. And here we need to say new instance instead. So this is the way we would usually do this instead. This is the new way of doing it. In the documentation, you would see the old way where you're using new instance right away. Here we have fly around, that is the spaceship, and there's an exception that can be thrown right here. I'm going to add that to the method signature, no such method. That is if the constructor does not match. Add exception, yes, also add exception, illegal. Yeah, then we have illegal access. That it means that if the scope suddenly is not, if it's not visible, if the constructor is not visible, and then we have invocation target exception, and instantiation exception. That is if something goes wrong when we try to instantiate it. So now I've actually created, you can actually see here right now, the type is actually spaceship. The type is actually spaceship. Did I really want that? Let us just see here. We actually want something that extends. Yeah, that is because if you can actually see up here we have the class capture of something, a question mark that extends spaceship. So we know that this is actually not the spaceship, it is something that extends the spaceship. What we could do now, first of all, let us just see what actually happens if we print it out, fly like this. Let us just print it out, fly around. So now we have created a new version of a spaceship, and we could also, I would actually also like to get the name of the class name, because now we have an instance of the class, and then we say get class.get name right there, and then I would like to see that it actually shows dk.mic.slowSpaceship. let us run this program. Oh, no, let us not run this program right here. Let us run this program right here. And should I jump to the top? No, I don't need to. Look, fly, blah, 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 blah. That was not so good. Fly around. Oh, I forgot to call fly around. It's because, okay, let me just refactor this. Mike's ship instead. It's a bit easier to follow now. Mike's ship, of course, Mike's ship can fly around, and we can also get the class and get the name, of course. Let us run the test again. So right now we can actually see it says swoosh cough cough, and the class name is actually DK Mike slow spaceship. What if we had another method? Would it also override that? No, of course you have probably guessed it, that it would not do that unless, of course, we tell it to. We can also say land, and then we say splash, because it lands in water. Let us pretend that. So that means that then we can fly, and then we can land, just to show that we actually take something from the original spaceship. Let's say land like this, and then we press run again. Then we have splash, fly, and then we have the name of the class right here. So it is a new class that we have created. We have added it to, we have loaded it in the class loader, and we have also now run the methods. If you had to use reflection instead, then this would be much slower, because you would invoke your an instance right away. And in this situation right here, we just create classes that we add to the class loader. We don't need to call the last. We actually don't need to call these 3 lines right here, so we don't need to load it right away. That is one big benefit, of course. So it performs. They have designed their frameworks that performs better than the frameworks that they are competing against, or the frameworks that they are comparing themselves against. Really cool, right? This is really awesome. Let us try something a bit more advanced, because let us say that we had a. Okay, let us. Okay, I'll create a class named shooter. Or my static code, just to show my static code. Yeah, let us just call it that. And then we have some public static string, and then we have shoot like this, and then we return kaboom something. So now of course you've probably guessed that I want my spaceship to shoot, but the original spaceship, this is a peaceful spaceship, so this cannot shoot at all. But the new class that we are creating, that is not a peaceful spaceship, so we want to add some more. After this method has been defined right here, and after we have intercepted it, then we can actually say define method. When we call method like this, then it needs to be there already. So then it needs to be present already. Here now we're going to define method. So this is a new method that we're going to define, and here we have shoot something. That is the name of it, and the return type, that is a string or class, and that is actually it. And here we can say intercept, and so, I saw in the documentation usually they actually place intercept. A lot of times they place it on the same line as the method, so it's easier to see what goes together. And here we can use something called method delegation. Method delegation dot to, and then we can just mention the class my static code, because there's only one method right there. Class, because there's only one method there, I actually don't need to do anything else. Or else I could also give the name. I could actually also add the name here in the intercepts to the class, and then we could say. We could say something else, so we could get we can be more specific and actually say which method we actually want to use. But right now we only have one method up here, so we would actually like to see that it should say kaboom when we are shooting. Another thing that is usually done is actually that you would actually usually create an interface, because it's much easier than to call the code in your, or else you have to use reflection to call the code, because I don't have any, in my code I don't have anything that actually uses shoot right now. So we could actually have an interface that could be called shooter, something like shooter, right here. And here we could have a, method called, what should it be? Here we're going to have a string and then laser shot or something like that. I'm trying to show that it does not need to match the other code. It could also be a default methods, where we actually have these are the new default methods that we got in Java something that I've forgotten. Was it 8? I'm not sure. I will not. Yeah. So we have these default methods right now. That means that we can actually return something, and then we say. So that is the laser shot right here, and that means that we can actually. Go to our class, which is kind of it's kind of messy soon. It's kind of messy right here. Then we say define. We can say define method, but that the problem with that is that. Then we need to use reflection to call shoot something afterwards. So instead of actually defining a method, I would actually like to implement shooter.class instead, because then it's easier for me to call the methods. Yeah, you can play around with the define method yourself. I think you should. And then we have implement right here, and then we can say method. And what was the name of the methods? Laser shot, that was the name of the method right here. So then we say method, and then we say intercept, and then we say method delegation to. I need to surround this with named. This is element matches, and then we want to intercept that method, and we want to use method delegation from my static code. So you can actually see right now the method does not match the other method. So we have one method right here, laser shot, which does not match my static code right here, where we have a method called shoot. It could also be called something else like sing. It does not matter what this method is called. And then we say first we say implement shooter, and then we say method named laser shots. The reason why I do this instead is, yeah, you'll see this in just a minute. We could also have defined a new method and intercept, and then we make it, yes, and then we continue. Okay, so now we're happy. So the reason why I wanted to do all that was because then I can write shoot, and then I can say, I can still not say laser shoot, because this the instance of we have created is a spaceship. It's actually a DK Mike slow spaceship. What I can actually do now, because I created an interface, I can actually typecast it without checking. Of course I should check, but now I'll just use shooter like this. Yes, it is very, very ugly. And that is also why I'm pretty sure I'm never going to use this. But if you want to use reflection for some weird reason, first of all, in 99.9% of all the cases, then you should actually not use reflection, or you should also not use this framework. And that, again, this is my own opinion. Feel free to write something else in the comments as usual. Okay, so now I have casted this to a shooter, and then I call the method laser shot right there. Let us try to run the program, see what happens now. Here we have it, kaboom! Kaboom! So let us say that I did not intercept the laser shot method, then the default code should be called instead. And now it is shoot. And that is because then we use this code right here. I hope you're confused now, because then you might want to read up on the stuff right here. I think that there's a lot right here, and it actually I had to try 3 times before I actually got to the end right here, because it is a little bit heavy. But it actually you feel good after reading all of this because you can actually see all the energy and all the things they have put into this framework right here, and you also get a brush up on your basic understanding of classes and class loaders and methods and scopes and annotations and stuff like that. I think actually it's quite good brush up, and you feel like you actually got some of the things you might have forgotten a little bit. Maybe you actually started learning a little bit about that again, because we are building classes from scratch. We are also subclassing, we're redefining, and we're rebasing other classes through this framework right here. Yeah, so read this. I'll put this in the readme.markdown file, which we have. We don't have one actually. I will rename the help.markdown file. This is one that Spring always creates for me. So here now I have the link right there. Thank you very much for watching, and I hope you have a great evening. And join the Discord if you want to talk to me or some of the other guys and girls in the Discord server. Thank you very much for watching. I hope to see you again very soon. Have a great evening. Bye bye.